Let's talk about Unit 1, Prints, the Language of Industry. Engineering drawings are a universal language used by machinists, engineers, drafters, and end users to communicate information about a product. Drawings contain all of the information needed to fully define the shape, size, and characteristics of the product. So this could be major things like the length and width and weight, or minor things like the color of paint. It should all be on the drawing. So you might wonder why the book is called Print Reading, and I'm talking about engineering drawings. The reason is they're almost interchangeable, but not quite. A blueprint or a print is just a copy of a drawing. The real drawing is usually under lock and key at the company that created the product. So the reason being, one, they don't want people to take their ideas. The other, they don't want people at the company making changes to that product without proper authorization and following procedures. So in this course, I'm normally going to talk about the engineering drawing. Some drawings are printed, although very, very, very few are made by hand. Although now a lot of drawings are being stored on computers, either as their native CAD file, so something like AutoCAD or SolidWorks, or as a PDF. A PDF has the benefit of being easily emailed and transported through cyberspace. Another advantage of the PDF is it's difficult for the end user to change the drawing. And this matters because drawings are legal documents. Drawings hold the same weight as something like a contract. So when you accept a quote for a drawing, you accept that you're going to recreate everything on that drawing perfectly. If you don't, say a drawing says to make something 12 inches long and you make it 9, right? You're in breach of contract for not following that drawing. One important thing about engineering drawings is that they have to be standardized. They can get very complicated very quickly, and everybody needs to be on the same page about how they understand the drawings. So usually countries or groups of countries will have standardization agencies, which I'll talk about in a little bit. A little bit of history of drawings. We won't go too deep into this, but I'm sure everybody knows drawings used to be made by hand. It used to require a lot more people power to make a drawing. You would need to have one person sketch it out in pencil, another person would come through and ink it, another person might take it to the blueprint machine to have it copied and reproduced. Now, far less people are involved in making drawings, but they're far more technically capable per person. So, drawing standards. A standard is a guideline that a company might modify to suit. So companies typically try their very best to do exactly what standards tell them, but occasionally companies will have to veer away from what the standard says for their own interests. Two of the largest drawing standards organizations are ASME, the American Society of Mechanical Engineers, and ISO, the International Organization for Standardization. ISO is based in Europe, so a lot of European countries and countries all over the world use it. In this class, we're going to focus almost exclusively on the ASME system, that's what's used in the United States the most. So standards allow drawings to be used without contacting the person that made the drawing. So this is important with products that are going to be around a very long time. So things, military items, ships, nuclear power plants, these are all going to be around for decades. So the drawings have to be made to a standard. Even if the standard is superseded, you can go back and find it. Some of the ASME standards through the years look something like this. This is 1973. 1982, 1994, and 2009. There's a new one, 2018, that I don't have on me, and there are a few older ones. The first one was published around World War II, and it was called something different. All of them have information that if you get a drawing from the 1950s, you can go back, look, figure out how they did it, and interpret the drawing correctly. That's the advantage of using standards. Let's talk about the design process. It's a 5-step iteration. So the statement of the problem, thinking of possible solutions, refined solutions, testing and analysis, and implementation. So drawings play a role in all of this because drawings are how the actual product is documented. One of the most important and difficult concepts with understanding and interpreting drawings is visualization. So we're going to take 3D objects and display them on a 2-dimensional paper. So there's certain rules we're going to use to make sure that you know exactly what somebody else is putting on paper. We'll go through that. There's 2 major systems: the first angle projection system, used often in Europe, and the third angle projection system that we use here in the United States. We'll talk a little bit about both in the following chapters.